Alrighty. All right, so now hopefully you all see my whiteboard, right?
Yes.
Alrighty. So today we're going to be talking about, all right, circles and specifically about circumference, all right? So we're going to introduce circles and specifically about, so our objectives, and this is going to be posted, fellas, so don't worry about if you miss something, right? So we're going to talk about parts of a circle. All right, so we're going to talk about parts of a circle, but then we're also going to deal solving problems using circumference. All right, so that's what we're going to be doing today. We're going to talk about parts of a circle, and then we're going to solve problems using circumference. All right, does that make sense? Hello?
Sir.
Guys, you got to talk to me, right? Because I can't really see you. All righty, so when we deal with circles, circles are different than the rest of the things we talk about because the other things we talk about have sides that are straight. So their measures are kind of easy. The problem we have with a circle is that it's not made up of lines, all right? But there are segments in the circle that we can use to help us that will take our circular or our linear measures and make them circular. So circumference is sort of like perimeter, but it's easy to do the perimeter. All right? It's easy to do the perimeter because we can just take out a ruler and measure the sides. Right? It's kind of hard to do that when you have a circle, so we use different peaks. All right, so the first thing we want to do is let's make sure we know what a circle is. All right? Right? And a circle is simply a set of points. Right? A circle is simply a set of points, right? And it's all the points the same distance from a given point, and that given point is called the center, all right? So a circle is all the points in a plane the same distance from a given point called the center. So if I had a circle, this point right here is what we call the center. So if I said this was C, point C. So when you name a circle, you name it from the center point. So you can simply call it circle circle C, or you can use this symbol, and that means circle C as well. Does everybody understand that?
Yes, sir.
All righty. So, but the problem is, that's not line segment. But there are some line segments. There are some line segments in our circle that we are very familiar with, right? So, when we talk about, the first one we're going to talk about is the idea of a radius, okay? And a radius, these are all line segments, all right? And the plural of radius is radii, all right? So, all we know about a radius is it is a line segment, all right? It's a line segment with endpoints, right? At the center of the circle. And you have to memorize this, right? And a point on the circle, okay? So if I have a circle and I have a line segment, I'll make it blue, right? This line segment right here. This is point C. This is point B. Well, that's circle C, right? And line segment CB would be considered a radius. Why would it be considered a radius? Because its endpoints are the center of the circle and a point on the circle. Does everybody understand that?
Yes, sir.
All righty. Now, a circle has a lot of different radii, right? A circle has a lot of different radii. These are all radii. And what do you know about all the radii? They are all the same
Distance.
measure. Yeah. So because that's the definition. Look at the definition. The definition of a circle is all the points the same distance from a given point. So all of these segments, since they're all radii, have to be the same length. Does that make sense? Hello?
Yes, sir. Yes, sir.
Yes.
All righty. Next segment, a chord. A chord is simply a line segment. These are all segments, right? A line segment with endpoints on the circle. So unlike the radius, where only one of the endpoints was on the circle, a chord, both of them are on the circle. So for example, this would be an example of a chord. This is circle C, right? Here's an endpoint. Here's an endpoint. That line segment, I'll call it AB. In this picture, AB is a chord. Any line segment that has two endpoints on the circle, any line segment that has two endpoints on the circle is called a chord.
Picture
All right.
ready?
Yes.
My internet is like being really slow, so you keep cutting out. Do you mind just slowing down a little bit?
Yeah, that's fine, but whatever you miss, it'll be posted again too. So like if it cuts out and comes back, you'll get it when we get it posted too, all right?
Okay.
But I will slow down, all right? That's no bother, all right? Now, so we know what a chord is. It's a line segment. Now, who knows what special chord we're going to talk about next? Yeah, very good. Here is a picture of a circle, and there's the center. We'll call it circle C. Now, there are some segments that we would consider chords because what do you know about A and B? They're both on the circle. So AB is technically a chord, but it's a chord that does what? It goes through the center of the circle. So what do we know? What would we call that? We call that a diameter. So any chord that goes through the center of a circle is called a diameter. Now, let's take a closer look at the diameter. And what do you know about this part right there? What do you call that?
It's a radius.
That's a radius. And what do you know about this part?
It's equal to that part.
That's a radius. And since they're both radii in the same circle, they're equal, right? Well, they're congruent. But what do you know about the two if I put them together? What do you get?
Diameter.
You get a diameter. So you need to keep that in your head. The diameter is always equal to 2 times the radius. And that's going to be more important for us in a few minutes, all right? So those are the segments we're going to talk about. Radii, chords, diameter. We know that all radii are diameter. We know that all radii are congruent, right? We know that 2 radii equal a diameter. Well, if all radii are congruent, and a diameter is made up of two radii, then we know that all diameters are congruent. But we want to remember this always, right? Don't ever forget this, right? Does that make sense to you guys? Hello?
Yes, sir.
All righty. I'm going to draw a circle. I'm going to put a few things on it. And I'm going to label it a little different, right? Now, given that circle, somebody tell me what you would call that circle. How would you name that circle? Circle what?
Oh, wait,
Circle C.
Circle C, right? You always name the circle by the point that's the center of a circle, right? Now, what if I asked you for a radius? Somebody give me a radius.
CF.
CF. What else could you give me?
CE.
CE.
Yeah, we got CF. We also got
CD.
CE, right?
CD.
And then you got CD. Very good. Whoever got TV on, turn it off. All right? Now, what about a chord? Somebody give me a chord.
AB.
Well, AB, because what do we know? Line segment, look what we got. We got a line segment where the two endpoints are on the circle. Is there another one?
DE.
Yeah, very good. DE, right? What do you call a line segment that's two endpoints? What do you call a chord that passes through the center?
Diameter.
Yeah, that's the diameter. Hey, what do you know about the measure? Very good, guys. What do you know about the measure of this and this?
They're the
and
same.
this? They're all the same. Why? Because they're all radii. Does that make sense?
Yes.
All right. Everybody got that? Everybody clear with that?
Yes, sir.
You all right there, Buchanan? Buchanan, you all right? Hello? All righty. Comprende? All righty. Now, anybody know what that is?
Pi.
Pi.
Very good. Pi, right? Somebody give me an approximation.
3.14.
4.
Yep. Or what could you use if you were using fractions? 22/7, right? If you were using a fraction, you would use 22/7, right?
Yes, sir.
But most of the time, we just use 3.14. Now, here's what you got to remember. The symbol pi is exact, and this is an approximation. So sometimes you're going to see, give me the exact. That means do not change that to that. Does everybody follow that?
Yes.
Now I want to see who is a math student. Where does pi come from?
The circumference of a circle.
The circumference of a circle. Go ahead. What's that?
Circumference over diameter.
Yeah, any circle in the world, if you took its circumference and divided it by the diameter, you would get pi. So, if you look at the middle of a basketball court, what's in the middle of a basketball court?
Circle.
Yep. What's a quarter?
A
A
quarter.
quarter, you took a quarter out of your pocket. What shape is that?
Circle.
Yeah. What about the face of a clock? Right? They're all circles. And what do you know about all of those circles, right? If you took the circumference of that circle and divided it by the diameter, you would have to get 3.14. Right? Does that make sense?
Yes.
All right. So now we're getting a little bit ahead of ourselves, but that's okay. But we just wanted to bring that up just so you were aware of where pi comes from, right? But I got a little bit ahead of myself, so don't freak out too much. All right. So here's what we know. That there's a relationship between the diameter and the radius. The diameter is equal to 2 times the radius. Or the radius would be equal to what? Right? What would the radius be equal to? The diameter divided by 2. So, whether or if I give you the radius, really what I'm giving you is the diameter as well. If I give you the diameter, I'm also telling you what the radius is. You just have to use the information you got. Ready? So let's do a couple of problems where we work on that. Ready? So I'm going to draw a circle. And I'm going to call this circle Q. All right? Because the midpoint, the center is going to be Q. And then I'm going to draw this segment, QV. And then I'm going to draw this segment right here. And I'm going to call that TU. Now, if TU looks like a diameter, why does it look like a diameter? Because it is. How do you know it is? You know it's a diameter because it's 2 endpoints, T and U, are both on the circle. What do you know about QV? That's a radius, all right? So here's what I know about all of these segments. These have to be true. All righty? Does that make sense? So if I tell you if QV, right? If QV is equal to 8 meters, if I tell you that QV is equal to 8 meters, what is the diameter of circle Q? Well, QV is this part right here. And I tell you it's 8 meters. What did I just tell you? I told you that R was equal to 8. Do you guys agree with that?
Yes.
All righty.
Yes, sir.
Well, what am I asking you for?
Diameter.
I'm asking you for the diameter. So what's the relationship between the radius and the diameter? Well, I know that D equals 2 times the radius. Well, I know I know the radius, 2 times 8. So what's D equal to?
16.
16 meters. Does that make sense to you guys?
Yes, sir. Yes.
All right. That's not brain surgery, right? This should be sort of like a review for you, right? Hello?
Yes, sir.
Yes.
All right. I'll give you another. Huh? Somebody have a question? All righty. What about this one? If I tell you that TU is equal to 14 feet, TU equals 14 feet, what's the radius? Well, if I tell you TU, what is TU? Well, where's TU? Right here.
Diameter.
Yeah, TU is the diameter. So I'm telling you that the diameter is equal to 14. So what's the relationship between the diameter and the radius?
The radius is half of the diameter.
Yeah, the radius is the diameter divided by 2. Well, I know the diameter, 14 divided by 2. What do we got?
7.
7 feet. Does that make sense?
Yes.
I don't think that's too bad, right? You probably knew all that, right? Probably knew all of that, right?
Yes.
Let's do one more of those. And all we're trying to work on is the fact that the relationship between the diameter and the radius is half the diameter. All right, so here's the next one. QT equals 11. And they want to know what QU is. All right. Well, QT is where? Right here, yes?
Radius.
So that's a radius. So really what they're telling you is that R equals 11. Now, they want you to tell them what QU is. Well, where's QU? Well, what is QU?
Another radius.
QU is another radius. So what do we got? So if QT is 11, what's QU?
5.5.
No, I made a mistake here, fellas. QU.
11.
Yeah. So this is QT,
Right.
and you know that that's 11. This is QU. What is that? That's also a radius. So what does it have to be?
The same.
It
11.
has to be the same because all radii are congruent. Does that make sense?
Yes.
I sort of screwed up the diagram there at the beginning. Does that make sense?
Yes.
All righty. So far, so good?
Yes, sir.
Does anybody have any questions right now?
No, sir.
All righty. Now, let me get rid of that. All righty. Now, sometimes they have what we call intersecting circles, right? We're not going to spend too much time on this, but I just want to bring it to your attention. Sometimes circles intersect. What does that mean they do? They hit each other, right?
Overlap.
So, yes?
I just said overlap.
Yeah, they overlap or they intersect. Now, they can intersect at 2 points or 1 point, or they don't at all, right? So that's easy. That's two circles that don't intersect. What do circles that intersect at 1 point look like? They look like this. But what do circles look like that intersect at 2 points? Right? They look something like this. And there's the 2 points where they intersect. Does everybody understand it? So those are the three possibilities you have. All right, now, this circle right here, the big one, that has a center. This other one here on the right has a center as well. And all you need to know is that if you connect those two segments, that segment, right, contains the radii of both circles, okay? This is the one we're talking about right now. And we're not going to try to get into it too much, right? I just want to introduce it to you so that you know that when you have circles that intersect in 2 points, you have circles that intersect here and here, right? If you connect their centers with a line segment, that line segment will actually contain the radius of both. So if you look at this one right here, there's the center, there's the radius, right? If you look at this one right here, there's the center, there's the radius, right? So that line segment has both radii in it. Does that make sense? Right? And you just use that to your own advantage. But I'm not going to get too stuck on that one, right? All right? Does that make sense? Really what we want to talk about is using the circumference, all right? So we know that the circumference is always equal to what? the circumference divided by the diameter is always equal to what?
Pi.
Pi. All right. Well, now we can use that to our advantage. Because if I took this equation right here, and I wrote it, so not that it said pi equals, what do I have to do to get it to say c equals? What would I do to this equation?
Times it by diameter.
Multiply both sides by d. And I'd be left with c equals pi d. All righty. Well, now you have your formula. For the circumference of a circle, you just have to do pi times d. Now, what's d equal to? What do we say the diameter is equal to?
2 times the radius.
2 times the radius. Well, if I have a formula that says pi d, and I know d and 2r are the same, can't I just take the d and change it to 2r and get 2 pi r, right? So those are your two formulas that you need to know. So between c, d, and r, right? If you know d, you can tell me the circumference. If you know r, you can tell me the circumference. But you can also take, if you know the circumference, you could tell me d or r. So let's do a little bit of work on that. Now, I'm not going to draw the pictures, but here's what I'm telling you. I have a circle, and I'm going to call it circle F, all right? And circle F has a diameter of 79 feet, okay? So this is what it looks like. If I said to you, somebody tell me what the circumference would be. No? I know the circumference is pi d, right? I know d, right? And I'm looking for c. So the circumference is pi times 79. And then what do I change pi to?
3.14.
And then I just whip out the old calculator and I come up with, and it's not equal to, it's about, right? Because pi is an approximation, right?
148.06.
So you got about 248, about 0.19, I think, right?
Or is it
Does that make
0.06?
sense? All right, whatever, right? I didn't do
Oh,
that
okay.
much, all right? All right, does that make sense, guys?
Yes.
So,
So,
all right, so now I'm going to give you another one now. This time I'm going to give you a circle, all right? So you're going to have circle F again, right? So here's circle F, all right? But I'm not going to tell you the diameter, I'm going to tell you the radius. So the radius is 2.5 centimeters. So this is 2.5 centimeters. Now, we know that the radius times 2 is the diameter. So I can use either one of these. I can use either one of these. I got pi d, or I can just use the radius, 2 pi r. They both give you the same answer because they're both the same answer. So which one do we want to use? Doesn't matter really. But if I use this one here, what's the first thing I have to do? They didn't give me what do you have to do to this?
Divided by 2.
You'd have to multiply it by 2.
Or
Very
2,
good.
yeah.
So I would just simply use 2 pi r. So the circumference is 2 pi times r, which we know is 2.5. 2 times 2.5 is 5, right? Now I take out my calculator, And 5 times 3.14, approximately 3.14, is approximately what? What did I do here? Oh. Approximately what? Hello? Approximately what?
15.7.
About 15.7. Does everybody understand it? All right, I'm going to give you one. You're going to work on your own. Ready? You're going to work this one out on your own. Ready? All right, so you got a circle. You got a circle, and you got a diameter. Diameter equal to 16 feet. What's the circumference?
Isn't it 50.24?
All righty. So if I just take the data,
Yeah.
they told me D. So I'm going to substitute what? 16 where I see D. And then I'm going to change pi to 3.14. I whip out the old calculator, and I should get something that says 50.27 feet. So the circumference would be about 50.27 feet. Does everybody make sense with that?
Yes, I put 2.14 on it.
Is everybody clear with that?
Yes, sir.
Yes.
All righty. Now, the reason we have to use the diameter and the radius is so that we can find the circular measure, right? So the radii and the diameter are linear measures. We use them to find the circular measure, all righty? Now, some people don't realize that you can also use this to find diameters and radii. So it's easy to use it like, so if I have a formula that goes C equals pi d. Well, everybody says, well, if you know d, you can figure out c. Well, if you take the same formula, but I tell you c, you can also figure out d. And fellas, if you can figure out d, you can also figure out r too. Why? Because r is what?
2D.
Half of d. So
Uh,
they're all related to each other, all right? So you always have to keep that in your head. So now we're going to use our circumference to find some other thing, all right? So if I tell you circle C has a circumference equal to 106.4 inches. Circle C has a circumference equal to 106.4 inches. Tell me the diameter and tell me the radius. All right, well, what's the formula we have? Circumference, right? Pi d, right? Yes? So all I want to do, I'm looking for what? I'm looking for d. So if I can go over here to my formula and get d by itself, because I already know c, right? So I'm going to substitute what I know for c. Now I just want to get, I'm looking for d, right? I just want to get d by itself. So what do I have to do to both sides to get d by itself?
Divide by 3.14.
Divide by pi. And now I have d equals 106.4, and I know pi is about 3.14. So now I know what? D is about, what's 106.4 divided by 3.14? About
33.8.
Yeah. Now, what if I said to you, tell me what the radius is? Well, what's the radius equal to? The diameter divided by 2, right? Yes?
Yes.
So 33.87 divided by 2 equals, right? What do you end up with? 33.87 divided by 2.
16.94.
All righty. Comprende?
Yes, sir.
All righty. Try this one on yourself. Ready? Let's see if we can get another one. The circumference of a circle is 77.8 centimeters. What's the diameter? What's the radius? Off you go. Anybody come up with an answer yet?
Diameter is 24.78 and the radius is 12.39.
So the diameter would be about 24.78. Good. And then the radius would be half of that. So that would be what? 12.39, right? Agreed?
Yes, sir.
And fellas, since we changed pi to 3.1, that means it's an approximation, okay? So you gotta be really careful because when they say, I want an exact number, then you gotta go and say, all right, I can't change pi to 3.14. I just leave it as pi. Does everybody follow that? Yes, no, maybe?
Yes.
sir.
All right, so are we all clear? So as of now, here's what we should know. We should know how to name a circle, right? We should know how to name a circle. We should understand the idea of radius, chord, diameter, right? Circumference, right? The distance around a circle, right? All right? We should know a few things about this, right? So all radii of a circle are congruent, right? All diameters of the same circle are congruent, right? The diameter is equal to 2 times the radius, right? We know that the circumference is equal to pi times the diameter, or if you want to use the radius, 2 pi r, right? So those are all things you've already learned, but that's basically what we've been going over. Does that make sense, fellas?
Yes, sir.
All righty. That's the first part. I don't want to get too much into the next part, but I'm going to bring it up to you anyway. So now, most of your homework is going to be, so circles and polygons. All right? So when we talk about circles and polygons, we're either going to talk about an inscribed polygon, or a circumscribed circle. Okay? Now, polygons are inscribed, circles are circumscribed, all right? So here's what that means, all right? A polygon is inscribed if all of its endpoints, its vertices, are on the circle. So for example, if I draw a triangle, right? There's a vertice, there's a vertice, there's a vertice. This triangle is called inscribed if all of those vertices are on a circle. Does that make sense? Yes, no, or maybe?
Yes, sir.
So the triangle is inscribed. All righty? Does that make sense?
Yes, sir.
Triangle A, B, C. Now, if you look at the circle, I'm going to call it circle P, right? If you look at the circle, right, what do you know about the circle? Well, if I look at this circle really carefully, all of the vertices of that triangle are on my circle P. So what I say is that P is circumscribed. So circle P circumscribes triangle ABC. Does that make sense? All right? You just need to know that that's what we call those. So in this picture, triangle ABC, right, is inscribed in the circle P. Circle P circumscribes triangle ABC. All righty? Now, doesn't change a whole pile of stuff, but you need to know the terms. So, for example, if I tell you you have a square, what do you know about a square? Somebody give me the definition of a square.
4 congruent sides.
A quadrilateral, right? Or it's parallelogram with 4 congruent sides, right? A square. And here's what I know about the square. My square has a side that's 9 inches long, right? So what am I going to do? I'm going to draw my square. There's my square, yes? Now, I tell you that the square is inscribed in circle J. What does that mean? It means, what the hell? It means that the 4 vertices of my circle, of my square, are on the circle. Does that make sense? So what I would say is that my square is inscribed in circle J. Or I would say that circle J circumscribes my square, right? So here's what I know. Now, if I said to you, right, my side is 9, right? What is the circumference of the circle? All right, now, if I ask you for the circumference, what do you need to know?
Diameter.
You either need to know the diameter or the radius. Now, watch what we do here. Ready? Watch. What do you know about this line segment? What's this line segment called?
Diagonal.
That's the diagonal of the square, but what is it of the circle?
The
It's a-
diameter.
It's the diameter. Now, I wonder if there's a way for me to figure out the length of that side. Hey, fellas, if this is 9, and this is 9, and this is a right triangle, let me get rid of the stuff you don't need to look at. Oh. What's the length of that hypotenuse? If these two legs are the same, now you could use what? Yes?
Yes.
Hey, what do you know about these two angles? What do they measure? They're both
45.
Yeah. What do you know this is? That's the rules for 45, 45, 90, right? But let's say you didn't remember that. You still would have been able to do what? Right? 9 squared plus 9 squared, right? So c squared equals 162. And then you would have found out that this was 9 radical 2. But like if you had remembered, you would have remembered that that was a 45, 45, 90. You just would have done that. Now, I know the diameter. Because remember what we're working with. We're working with a circle. Now, what do we know? If my diameter is 9 radical 2, what's my circumference? Exactly. C equals pi d. All right, what's my circumference?
40.
Well, pi times 9 radical 2. Now, if I said exact, what would you do? You would leave that like that. Why? Why? Because that's an exact number, pi. If I said approximate, what would you do? If I said approximate, what would you do? Change
3.14.
pi to 3.14. Very good. All righty. Now, fellas, that was a lot of information. That was a lot of information. All right. So hopefully you didn't get too nervous about it. Let me give you one last problem while we still have a few seconds. I have a triangle that's inscribed in a circle. All right, Fogarty's not a great artist, but what the hell, right? And here's what I know. It's a right triangle, and its legs are 3 and 7, right? Find the exact circumference. This is the middle of the circle, by the way. Yes. Now, what do you need to know in order to find the circumference? What do you need to know in order to find the circumference?
Diameter.
Diameter. What do you know about the hypotenuse of that triangle? What is it? What do you call a chord that goes through the center of a circle?
Diameter.
Yeah. How do you find the length of that diameter?
3 squared
Yeah.
plus 7 squared equals
Yeah, 3 squared is 9. 7 squared is 49. So what's c squared?
58, or no, 58 squared.
58, yes, good. So what's c? Let's square root of 58. Let's see if we can actually reduce 58. Go ahead, 2 times 26, right? Yes? 2 times 13, right? 2 times 2 times 13. What is it?
2 radical 13.
Yep. 2 radical 13, right? So there's your diameter. So C equals pi times 2 radical 13. Now that's your exact answer. If I asked you to approximate, what would you do?
Multiply it by 3.14.
I would just take 3.14 and substitute it in there. I'd also take my calculator and plug that in there, and I'd get 3 point something else, right? Yes, makes sense? All right, kids, that's a lot of work that we did today. Does that make sense?
Yes, sir.
Hello? All right,
Yes.
so what I'm gonna do a little bit later on today, I'm gonna upload a worksheet to the Dropbox, and that's gonna be due Wednesday at 11:59 PM Wednesday. All right, so like you can look at it tonight and tomorrow, and you can ask me any questions you might have on it Wednesday, and then we clear that all up, and then you just get it done for Wednesday night at 11:59.
Is there going to be a link?
Yeah, well, no, it's gonna be in Blackboard.
Oh, in the assignments, or is it going to be like?
In the assignment, I'm gonna upload it now in a second.
Okay.
Does that make sense?
Yes, sir.
All right, does anybody have any questions right now? Anybody? Is everybody good?
Yes, sir.
We all good? All righty, guys. You guys have a good day, all right?
You too. Thank you.
All
Thank
righty.
you.
See you later. I have office hours at 2 if you need them.
Thanks, Coach.
All right, all the best.